Welcome everyone to EET 261 Communication Electronics. I'd like to go over your quiz number 10 solutions. Question 1, a common type of parallel wire transmission line was 300 ohm twin lead. That's true. Question 2, a well-designed transmission line is one that radiates RF energy. That's false. Question 3, coaxial cable is an example of an unbalanced transmission line. That's true. Question 4, maximum power transfer occurs in a resonant line. That's false. Question 5, a non-resonant line with matched impedances will dissipate power in the antenna like a resistive load does. That's true. Question 6, in a matched non-resonant transmission line, VSWR is equal to 1. That's true. Question 7, if the characteristic impedance identified as Z0 of the transmission line does not match the load impedance identified as Z sub L, there is a mismatch and reflections will occur. That's true. Question 8, calculate the electrical wavelength of a 60 hertz signal. So remember, lambda is equal to speed of light in a vacuum, 3 times 10 to the 8 meters per second divided by the frequency. So if we take 3 times 10 to the 8 meters per second and divide by 60, we'll get an overall wavelength of 5 times 10 to the 6th meters. Question 9. RG8AU coax has the following specs. The capacitance is 29.5 picofarad per foot, and the inductance is 73.75 nanohenries per foot. Calculate the characteristic impedance. So Z0, the characteristic impedance, is equal to the square root of the inductance divided by the capacitance. So if we plug the numbers in for the inductance, 73.75 nanohenries divided by the 29.5 picofarad, and remember, always get in base units, characteristic impedance should be 50 ohms. And then the last question, question 10, calculate the SWR when the characteristic impedance is equal to 50 ohms and the load impedance is equal to 300 ohms. So the expression for SWR is going to be the load impedance divided by the characteristic impedance. So I plug the numbers in, 300 divided by 50 is going to give me an SWR of 6. Thank you.